Welcome to chemistry in the AM. I'm not excited today. I am actually. I'm just trying to be subdued. And this is Joel Shindelga. Anyways, we're just going over some grams moles questions. We went over these ones, I think, at the end of the other class. I always get mixed up because I do it through period two. So just have these set up. This is the way you need to show your work with grams and moles, etc. We went over number 2 explicitly. Hello, good morning. So I'm not going to pause on that one. If you needed number 3, this is number 3. I'm going to pause the video and we're going to work through, I'm going to figure out one more attendance item and then we're going to work through the other worksheet. And then I got something for you. All right. Welcome again. Joining chemistry unit of physical science, the AM, in progress, live and recorded. Okay, I'm going to go through these here to make sure that we got it. Bear with me. I'll read 50 grams of magnesium react with silver nitrate in solution. How many grams of silver are prepared? Telling you, reminding you, it's single displacement. So we need the chemical equation figured out. Magnesium, I look it up on the periodic table. It's Mg, it's the element, there's no charge. Silver nitrate, I looked those up in the formula is AgNO3. Since I told you it reacts, you don't have to look anything up on the activities. It works. So silver's popped out, single displacement. And then magnesium has a 2+ charge, so it should be 1 dollar. Okay? That's your first thing. Then you balance it. I look 1 mg, 1 mg, 1 ag, 1 ag. Like NO3, single, or 1 on the left side, 2 on the right side. So I need a front number. That's the way down. This is how we do it. Okay. Anyways, I've got this balance. Stop me though, because I'm talking at the same time and I'm prone to making mistakes. Stop me if there's something that's different than that. Hello. I will pause the video for 1 second. So the next thing is, do it the same way every time. Write down, it's in words, magnesium, but we know the symbol. Write down what's given, 50 grams in magnesium. We're going to assume that's 2 significant given. When I have a 50 or a 500 or something like that. Assume the zeros, it's ambiguous, so you don't know that for sure. I'm just so grams, I want to get rid of grams. I use my periodic table. I go through this again and again and again. 24.31. 24.31. If I stop right now, I would have moles of magnesium. I don't want to keep magnesium. I want to get rid of it. So I look at the balance reaction. There's 1 magnesium for, what's the chemical that I want? How many grams of silver? There's 2. It's a 2 to 1 ratio. This is what I want. So if I stop now, I would have moles of silver. Do I want? No, I go to grams. So I look up silver now, and I'm only writing for 1 silver, even though the 2 is in green. The mass of 1 mole of silver is 107.87. Okay. If I stop now, what you're going to do is grams silver. Those are the units. The mass is just anything on the top, you multiply anything on the bottom, divide. I suggest you do it from left to right. 50 divided by 24.3 times the 2 on the top, 3 times the 107. Hopefully I typed it in, you guys will tell me. Did you guys get 443.72, blah, blah, blah? We're not going to keep all those digits. So I'm going to write this down. Small, and then I'll talk about round. 443.74 digits. I'm working toward getting you guys in gear for significant digits. 440, 2 digits. You're right. as I've got. I said, use 2 digits. That was ambiguous. If you wanted just one, you'd say 400. But I'm going to keep these. They don't have to be in the hundreds position, though. So that's why you don't chop it up. 400 forward. So here's 443, 444, I guess. I'm not going to mark the wrong. We're working on significant digits. I'm just not evaluating. Okay? I want you to be ready. There will be a time perhaps when questions about that. Now in front of you, so hopefully thinking. You need this self-total. Like I say the same thing. I'm going to look it up on the career. This is called times this. I want that to be implanted in your head. This one here, I at least have the reaction. Now look, there's no balancing required. 1, 1, 1, 1, right? 75 grams of coffee. Let's see you. I need moles. Now look it up on the periodic table. Coffee, 63.5. Okay, I have information about copper. Moles. I don't want, I want to get rid of copper. So now I have. And I want information about mercury. It happens to be Hg. I put the numbers in, even though they're ones, just to remind me I thought about it. Mathematically, it makes no difference. Now I have moles of mercury if I stop right now. I want grams or mass of mercury. So I got to get rid of moles. Chemicals mercury, so I look it up Hg, 200.5 now. That's one. There. I keep putting grams things. Only. Okay. Now that I'm stopping, I've got grams of mercury. 75 divided by 63.55 times 1 divided by 1 times 200.5. You guys did this 336.7 blah blah blah. So I'm going to keep. I'll write this down. This is what I'm covering. I'm going to keep 2 digits, so that's 240. $236 is closer to 240 than it is to 240. That's in grams, and that's mercury. Okay. I wouldn't mark you wrong on 236.7. Something properly rounded. Okay. But we're getting to this. Now, I just want to point something out. On the periodic table, you notice that mercury, most of these things are black, right? Anything red is a gas. That's why you got all the like helium gas, oxygen, nitrogen. You know those are gases. Hydrogen's a gas. They're red. Most things are black, meaning they're solid. Mercury is blue and bromine. Why? I just talked about gases and solids. You know mercury, maybe. Hopefully you actually don't have much in your house. It's liquid. It's a liquid metal at room temperature. Party out there. Anyway, so that's why it's blue if you ever wonder why. You know this one too? Yeah, it is. Anyways, so mercury is an odd metal too, and it's not good for your health, so you don't tend to do it. When I was a kid, I used to play with it by hand. I actually remember breaking thermometers on purpose to play with mercury. The 80s. It was a different time.
Yeah, it's before mercury could poison you.
It was before mercury could poison you. Yeah, we play around with all kinds of stuff. But it's really fun to play with, but don't do it. Because it's absorbed. Oh, because we didn't know how harmful it was. It's It's a carcinogen. How did you play with it? Well, I'll pause the video for a second here. Last one. All the buzz above mercury. 60 grams of aluminum. 60 grams of aluminum. React with hydrochloric acid. That's HCl. How many grams of aluminum chloride are prepared? It also produces hydrogen gas, and we're going to write the chemical equation for its spin balance. So I read this. 60 grams of aluminum. 60 grams of aluminum. Okay, aluminum. I haven't changed the color, just keep it consistent. Aluminum. That's the element. It doesn't, unless it's oxygen or something, it doesn't come into the It gets back to with hydrochloric acid, HCl. Aluminum chloride is prepared, okay? I know aluminum in a compound will be 3+, because I use my ion table. Cl with a minus. So AlCl3. Plus, they said hydrogen gas. Now, remember there's 7 things that comes with it's just the element, not in home. Hydrogen is one of them. Maybe you didn't remember that. I've got balancing on this. Right now, I take a look, aluminum to aluminum. So far, so good, but it's going to change. So I'm going to quickly do this here. I see Cl3. Okay, I'll put 3 here, then odd number, even number, that's not going to work. So I need to do the old, I've got basically in the other compound, 3 and a 2, I need to get to the same number. So like adding 1/2 plus 1/3, I need a common denominator of 6. I need to put 6 here. And then I say 2 of these, 3 of these. Okay, now the hydrogens are balanced. But I add the hydrogens. I mean, the hydrogens are balanced and the chloride, chlorine, chloride ions are balanced. But I've screwed up the aluminum, so I got to do better. Okay? All good then? I estimate that that would have taken you 2 minutes or so to figure out that before. Okay. Once you have that, you're ready to roll. You didn't. Hard to get the answer. Hard to find a good person to call. I'm going to assume 2 digits. And I know I need to get rid of grams. I need to get rid of moles. Aluminum. I look it up on the periodic table, the grams. 26.98. Here's my self-talk that I repeat every time. If I stop calculating right now, grams are gone. Oh, that's wrong. Oh. I would have moles of silver at this minute. I don't want silver in my answer, so I'm going to get rid of it. I put silver. It's aluminum. What's the old man thinking of, right? Nope, you ain't either, right? Okay, I'll write this down correctly. Aluminum. Okay. Now, 2 aluminums. What's the thing I want? Grams of aluminum chloride. So 2 aluminum chloride. I've now changed the chemical. Moles of aluminum chloride. I want mass of aluminum chloride, so I'm going to get grams on the top. So I add it up. 26.98 plus 3 groups of chloride, so 3 times 35.45. 133.22. All right, get a little rowdy. I guess I didn't change that color there. I usually use blue for this steps. divided by 60 divided by 26.9 times 2 divided by 2. If I recognize that's just 1, I don't need to enter, but put times 2 divided by 2. Times 133. I get 296.5. Is that correct? I was really distracted by thinking about it.
Oh, my God.
So, I'll put 296.5 more digits, but I'm going to round it to, this is where this one's goofy. I'm rounding to this spot, 2 significant digits. 296, well, up 1 is 300, isn't it? So, there it is. Agree with the teacher. That's what you just said. Okay. Throw 296.5 off. Wrong, but you're trying to work towards significant digits. You're prepared. Okay, this is where we're at. Guess what? I have something else for you. In this one, I'm going to ask you to do for evaluation. We'll self-mark it, but it'll be recorded.